Today's class, we are looking at trigonometry, and we are going to use today's class to focus on the trigonometry ratios and labeling the triangle. All right, so we're going to look at a right triangle that looks like this, and there's our right angle there. So that means that this is our hypotenuse, labeled as C. This is labeled as A for altitude, and then this was labeled B for the base. All right, so using what we learned about labeling triangles before, the angle opposite side C is labeled with a capital C, and the angle opposite side A here is labeled with capital A like this, and the angle opposite side B, this would be our angle B. All right, now when we're looking at our three trig ratios, the first one is called sine ratio. And the sine ratio is, all three ratios actually are all based on the angle that you're using. So in this case, if we were using this angle here, angle A, it could be labeled like this as well. Sorry, that looks kind of off, but for example, angle alpha here, and like so. The sine ratio is opposite over hypotenuse. All right, so it's opposite divided by the hypotenuse. So if we look at this angle and we're looking for its sine ratio, the sine ratio is side opposite divided by side hypotenuse. So in this case, it would be opposite, which is A, and hypotenuse is C. So that would be the ratio for the sine of this angle. If we look at next the cosine ratio, it's called cosine or COS for short, but it is cosine. I'll just write it here. So cosine, which is shown as cos, and then this one is just sine, S-I-N-E, or S-I-N for short. And we're still looking at this angle here. The cosine ratio is the side adjacent. Adjacent means beside over hypotenuse. All right, so again, looking at this side, the side adjacent to it is this one, the one right beside it. All right, because we know this one is opposite, this one is hypotenuse, so the side right beside it is this one B. So therefore, our ratio is going to be B over the hypotenuse, which is C. And the last one is our tan ratio. So tan of that angle. Tan stands for tangent ratio. And this one, the ratio is called, it's the side opposite over adjacent. All right, so again, opposite was A, adjacent is B, so our ratio would be A over B. So from these ratios that we just looked at, we have here S for sine, O for opposite, H for hypotenuse, C represents cosine, A is adjacent, H is hypotenuse, T represents tangent, O is opposite, A is adjacent. And from that, that's how we get this acronym SOHCAHTOA. TOA. All right, so this is a common method to remember the ratios that we just went over. So S represents sine. The sine ratio is opposite over hypotenuse, so opposite over hypotenuse. The cosine is represented as C here, adjacent divided by hypotenuse, so adjacent and hypotenuse. And then the tan ratio is opposite divided by adjacent, so tan is opposite over adjacent. All right, so that is just the acronym to remember those ratios. So SOHCAHTOA. Okay, so the first ratios that we had written out were all pertaining to this angle here. All right, we can write our ratios as well for this angle here, angle B. So that's what we're going to do next. I've just redo the triangle here. This was our right angle there. So now if we were to write out our ratios for angle B this time. So sine of B is going to be equal to opposite over hypotenuse. So I'm just going to write it like this, opposite over hypotenuse, just like we see here. Sine is opposite over hypotenuse. So this time, the one opposite is B, and then hypotenuse is still C. To compare that to the sine of angle A, it was A over C. Okay, because the one opposite was A, hypotenuse was still C. So because now we're looking at angle B, all our ratios will be pertaining to angle B. So cosine of B is going to be adjacent. So the one adjacent to angle B is side A. So this is adjacent over hypotenuse. So the ratio will be A over C. C is still our hypotenuse. And then the last one is the tangent of B, which is opposite over adjacent. Okay, so opposite of B is lowercase b, and then adjacent was A. All right, so that shows us the trig ratios for angle B. Okay, so in this example, we are given a triangle with angle alpha, angle beta, and we're given our sides. We have a side of 10, 6, and 8. All right, so I'm just going to label this depending on the angle. All right, so we'll look at angle A or alpha first, and we're going to get the sine ratio for it, and the cosine ratio for it, and the tan ratio for it. All right, and just remember SOHCAHTOA, like so. All right, so when we're looking at our angle alpha, the side opposite to it is 6, the side adjacent to it is 8, and 10 is the hypotenuse for this triangle. All right, so sine ratio is opposite over adjacent, opposite over hypotenuse, sorry, opposite over hypotenuse. All right, so opposite this angle is 6, so 6, and our hypotenuse is 10. So there's our ratio, 6 over 10. All right, you can reduce this or put it in decimal. I'm just going to leave it as 6 over 10 for now, just to show from our triangle. Our cosine ratio is adjacent over hypotenuse. All right, adjacent to this is 8. And our hypotenuse, it's still 10. And the last one is our tangent ratio, which is opposite over adjacent. All right, opposite to this angle was 6. and adjacent to it was side 8. So those are the ratios pertaining to this angle here. All right, so next we can get our ratios for angle beta. All right, so our sine ratio for beta is still opposite over hypotenuse, but we're looking at beta up here. Opposite is 8, and hypotenuse is still 10. Cosine of beta is adjacent over hypotenuse. Beta is here. Adjacent to it is side 6. And the hypotenuse is still 10. And lastly is tan beta, which is opposite, which is 8. Opposite over adjacent. Opposite is 8. And adjacent is 6. All right, so those are the ratios, the trig ratios for angle beta.